In section 6 of chapter 5, we're going to take a slight detour away from rational expressions and equations. Technically we're not, but we're going to be utilizing what's called polynomial long division. This is going to look very, very similar to what you did back in grade school. In fact, those are going to be my first sets of problems. We're going to do long division. I'm going to review this process because, spoiler alert, what we're going to do on these two problems is exactly the same thing that we're going to do on polynomial long division. All right, problem number 1. I have 564 divided by 2. Back in grade school, you should have learned to divide by doing this. 2 divided into 564. And you'd ask yourself, what do I need to multiply 2 by in order to turn it into a 5 without going over? The answer is 2, because 2 times 2 is 4. Then we subtract that from the 5, and we're left with a 1. Bring down the next number. And now we just rinse and repeat the same process. What do I have to multiply 2 by in order to turn it into a 16 without going over? The answer is 8. 8 times 2 is 16. Subtract that. There is no remainder. So we just bring down the 4, and we ask one last time, what do we got to multiply 2 by in order to turn it into a 4? The answer is 2, because 2 times 2 is 4. There is no remainder, so your answer is 282. Problem number 2 has a little bit of a twist. Nothing major for an honors class or an algebra 2 class. We're going to take the 716. We're going to divide it by 3. I asked myself, what do I need to multiply 3 by in order to turn it into a 7 without going over? The answer is 2, because 2 times 3 is 6. Subtract 6 from the 7. You're left with a 1. Bring down the next digit, which is a 1. And then we repeat the cycle. I asked myself, what do I have to multiply 3 by in order to turn it into an 11 without going over? The closest I can get is a 9 by multiplying it by 3, because 3 times 3 is 9. Subtract. 11 minus 9 is 2. Bring down the 6. Then you ask yourself, what can I multiply 3 by to turn it into a 26 without going over? The answer is 8. Multiply 8 times 3 to get 24. We subtract the 24, and we're left with a 2. And depending upon who you had as a teacher, you got one of 2 or possibly 3 answers. You go 238 with a remainder of 2. That's nice, but we're going to go further. This is actually where you got mixed numbers from. 238 and 2/3. It is the remainder over the divisor, what you were dividing by. I'm not a big fan of that because I want you to realize it's 238 plus 2/3. We're going to utilize that in a second. These are the problems we're going to be doing today. I'm going to give you one long polynomial, like the red one, 2x cubed plus 7x squared minus 14x plus 5. And we're going to divide it by another polynomial, like 2x minus 1. The way I set this up, the way I approach this problem, and the way I solve this problem is no different at all from the elementary school problems I just got done doing. I am still going to take the 2x minus 1, and I'm still going to divide it into 2x cubed plus 7x squared minus 14x plus 5. I'm still going to approach this the same way. I ask myself, what do I need to multiply the 2x by in order for it to turn into a 2x to the third? Here's the one kicker that makes this different. You need to make them equal. So I don't want this to be close to 2x cubed. I want it to be 2x cubed. I multiply 2x by x to the second power. Then I'm going to take that x squared and I'm going to multiply it by both terms. X squared times 2x is 2x cubed. X squared times negative 1 is negative x squared. I'm going to take that quantity and I'm going to subtract it from what I am dividing into. This step should always follow. The first terms should always eliminate. If they don't, then that means you picked the wrong number up here. And then we follow. 7x squared minus a negative x squared is the same thing as 7x squared plus an x squared, which gives me 8x squared. Bring down the next number. And then we repeat the process all over again. I ask myself, what do I need to multiply a 2x by in order to turn it into an 8x squared? The answer is a positive 4x. I take that 4x and I distribute it to both the 2x and the negative 1. 2x times 4x is going to be 8x squared. 4x times negative 1 is going to be negative 4x. I take that and I subtract it. Here's a bit of advice. Write the parentheses and then put the subtraction symbol. If you don't, you will at one point forget that you're subtracting these two things, and instead you will add them together and get the wrong answer. These two terms should always eliminate. Then I have a negative 14x minus a negative 4x. I'm subtracting a negative, so I'm really adding a 4x. Negative 14x plus 4x is negative 10x. And final steps, we got that plus 5 we carry down, and we repeat the process. What do I need to multiply 2x by in order to turn into a negative 10x? The answer is negative 5. Distribute that to both terms, you'll get a negative 10x plus 5. We subtract. Everything eliminates. There is no remainder, which means my answer is x squared plus 4x minus 5. There is one little twist that I want to make sure you're aware of. And I'm going to do an example. 2x cubed minus 1 divided by x plus 3. I'm going to set it up the following way. X plus 3 divided into
is that squared or cubed?
2x cubed. Notice there is no x squared term. There is no x to the first power term. It just goes from the third power to a minus 1. You need to put placeholders in your long division problem. Otherwise, at a certain step along the process, you will run into two terms that will not combine. So I need to put a plus 0x squared plus 0x minus 1. You need to make sure all of the powers of x are represented. You'll see why in a second. I ask myself, what do I need to multiply x by in order to turn it into a 2x to the third? The answer is 2x squared. Take that 2x squared and distribute it to the blue x plus 3. You'll get 2x cubed plus 6x squared. Put that in parentheses and we're going to subtract it. Here's why you need to put that placeholder. If I did not put that 0x squared here, the negative 1 would have been here. Negative 1 and 6x squared do not combine together, and you would have been stuck. That's why we need these placeholders. Lo and behold, the first terms eliminate. You'll get 0x squared minus 6x squared, which is negative 6x squared. Bring down the next term, plus 0x. And then we repeat the process. I ask myself, what do I need to multiply x by in order to turn into a negative 6x squared? The answer is negative 6x. When I multiply the negative 6x to the x and the 3 that are in blue, I will get negative 6x squared minus 18x. When I subtract, these eliminate. I'm left with 0 minus a negative 18x, which is just positive 18x. Then I bring down the negative 1, and we're in the home stretch. The number that I have to multiply x by in order to make it an 18x is 18. And that'll give me 18x plus 54. And here's the other thing that makes this problem different, is this problem has a remainder. The last problem didn't. But we're going to treat that remainder just like I did on the second problem from my elementary review. We're going to add the remainder over the original divisor. And that's our answer right up here.